So, welcome everybody. I am Laura Manfre from Italian company Nucleco. I am responsible for management of nuclear processes and nuclear specialized projects. And today I want to talk with you about the Italian regulations and the criteria for clearance in the nuclear field. And I will present you some practical examples. So, the radiation protection in Italy is regulated by the Legislative Decree 101 of 2020 and all its modifications. And as we already said, based on the concept that any practice involving radioactivity requires a justification, clearance refers to the removal of regulatory control from radioactive materials or objects that were previously part of a regulated activity once they meet specific criteria for radiological safety. And I've seen very, very clearly these in Europe, thanks to Lionel. But what in Italy? So according to the Italian law, within practices involving radiation sources, it is essential to distinguish between what is exempt from radiological constraints and what can be released without radiological constraints. These two concepts are strictly connected with the definition of exemption levels and clearance levels. So what about the exemption levels? Are the values set by a competent authority or by legislation expressed in terms of activity concentration or total activity, at or below which a radiation source is not subject to the obligation of notification or authorization. From the other side, the clearance level are values set by laws expressed in terms of activity concentration at or below which radioactive substances or material resulting from any situation of exposure to ionizing radiation are exempt from the provision of the law. So the management of the practices with radiation sources linked with these two definitions is specified inside the Decree 101 of 20 with the Title 7 and the Annex of the Decree, Annex 1. So in the Title 7, these concepts are specified and discussed about inside almost the most important article that are Article 46, 47, and 54. With the Article 46, the law gives us the description on all the practices that must have a notification or authorization. So in other words, all the practices for which we can ask a clearance authorization if necessary. I mean, for all the materials involved inside the practices. The Article 47, on the other side, gives exactly the opposite indication. So it says what practices can be exempted from the obligation of notification. And here, in the first time inside the Decree 101, are given the so-called exemption thresholds levels specified in the Annex 1. And if the quantity of radioactive materials do not exceed these levels, can be considered exempted from the obligation of notification of practices. The same, of course, is for the concentration of activity. Then the Article 54, and here, I think it's the most important for our topic today. That's the description of removal from authorization regime. The article says that solid, liquid, or gaseous material containing radioactive substances that come from practices subject to notification or authorization exceed the scope of the decree if they comply with criteria, methods, and levels of radiological non-relevance established for free release in Annex 1. If, of course, the authorization for their release is issued, because we cannot absolutely dispose any solid, liquid, or gases into the environmental for any reason, so for recycling, for reuse, or everything, if there is not an official authorization for the release. The authorization for free release establishes specific requirements relating to the level of release for materials, the method of verifying these levels, and specific constraints on the total activity released in a given period of time. Then we move to the Annex 1. Inside the Annex, there are actually all the clarification about the articles we just have seen together, and gives specific information about the methodology to use. So practices are considered to be devoid of radiological relevance and exempt from the provision of the degree when the following basic criteria are met. So if the practice is justified, if the radiological risk to individuals are negligible, and if the practice is intrinsically safe. In accordance with the basic criteria above, a practice can be considered without further justification to be devoid of radiological relevance when all possible realistic convincible situation, the effective dose to which any member of the public is expected to be exposed is equal or less than 10 microsievert per year, and that's the same everywhere. I mean, the same everywhere in every other countries. In application with the criteria of non-radiological relevance, practices with artificial radioactive materials or with natural radioactive material treated for their radioactivity, fissile or fertile properties are subject to the provision of the degree when for such material the radioactivity and concentration cannot be neglected. And when they cannot be neglected? When the total quantity of radioactivity for the radionuclide is equal to or greater than the values reported in table 1A, and when the average concentration of the radionuclide is equal or greater than the values reported in the same table. Okay, I think we can skip that, just to show you some values of the table that are expressed in terms of concentration values and in terms of total activity values. So, from the other hand, the release of material are established in the authorization action in compliance with the criteria on non-radiological relevance of practices. For solid materials, there are special levels, and the mass concentration must not exceed the values reported in table 1B. And okay, of course, the authorities responsible for the issues of the authorization action may also establish additional release level expressed in terms of sulfate concentrations or specific requirement to verify the release action levels. And of course, the specific requests are in accord with the European Commission guidelines. Just to show you the slight difference, this is the table for the release of solid materials, and are expressed only in concentration values, and there's a slightly little difference within the level of table 1A. For example, it's very obvious for tritium that the level is quite different. So that's actually the legislative background where we have to move into to request release and to operate clearance for our materials. Now let's move to the practical point of view, and let's talk together about the clearance process for the nuclear installation and the materials here in Italy. So the clearance process ensures that materials, buildings, or sites with residual radioactivity are safely released from regulatory control. And we already say that can happen when the radiological impact is negligible. So here the following is a description of the stage of the clearance process in Italy from the time an object is identified as potentially clearable till it can be free released. So what are the steps? What are the stages? Of course, at the beginning, we must have a preliminary evaluation and planning of our clearance. So understanding what kind of material or part of the sites of buildings or components we want to release. And at the same moment, understanding the story of these objects to plan a proper measurement and radiological characterization. Once we have our results, we can compare these results with the clearance levels. And if our results exceed the clearance level, of course, we have to plan a treatment or a decontamination if necessary, and repeat again the measurement, and so on till our level are under the clearance level. Our results are under the clearance levels. Once that the results are under the clearance levels, we finally can prepare a clearance request and submit it to the competent authority. The clearance request is reviewed and authorized officially by the competent authority. And only in this moment, the material or the site is finally released. So let's go through the stages one by one about the preliminary evaluation and planning. So to plan our clearance request, we first have to identify the materials or the area subject to our clearance. That means that we have to assess the historical radiological information of the site, collecting records, operational history, documents, and everything is known about it. To understand what kind of measurement to perform. In this moment, we can prepare the so-called piano di rilascio, so the clearance plan that must include several information that are, let's say, officially requested from the competent authority. So we must specify the materials area involved. We must specify the clearance levels. We must specify the accepted radionuclides, the measurement methodology we want to use, and to justify the request of clearance for these materials. At this point, we can submit the plan to the control authority. So this information here, in order to predict the type and the potential level of contamination and therefore select the monitoring strategy for the release, it's necessary to define the characteristic of the material we are investigating in. So it means we have to be sure about the material source in terms of type of plant and plant area or specific use of the object during the activity. We have to know about the material type, so means physical form of the material, if it's concrete, if it's steel, if it's plastic, and so on. Then we have to know the material quantity, so estimate or measure the quantity of material in terms of volume, mass, of area. Then we, of course, have to know what kind of radionuclides to investigate. So specify radionuclides present and type of emissions, of course. The type of decontaminations of our materials. So physical characteristic of the contamination, if it's only a surface contamination, if it's a mass contamination, if it's activation or combination of two or everything. And of course, if there's or not an homogeneity in the contamination. So identify hotspot on the surfaces or volumes. The materials usually are divided into homogeneous groups, identified by considering the radiological characteristic of the materials themselves, and on basis of the initial radiological characterization data available. Usually, the homogeneous group is made up of the same type of material. Okay, so once we know everything about our material and what kind of radionuclides to look for, we can start planning our monitoring strategy. That can be seen as a process in which the material to be monitored is the input of our strategy. The monitoring technique and the handling of the material itself are part of the process, and the final destination of the material, so if finally can be declared as clean and request to be released, or if it's declared as, let's say, dirty, it can be, must be considered as a radioactive waste. So in this case, the destination of the material is our output. Monitoring techniques represent a tool of monitoring strategy for the verification of the clearance levels. They combine the selection of an instrument with a measurement protocol that can be a direct or an indirect monitoring. For direct methods, the instrument is used directly on the material to be measured. For indirect methods, the contamination is transferred to a second medium or sample that is then measured. But what about our measurement and radiological characterization? So, perform radiological measurements means giving results, giving values at the end of total activity, on surface contamination, or on mass activities of our material. Once we have these values, we can use a validated protocol, so using portable detector or sampling the material, making laboratory analysis. And once we have our result, we need to follow national and international technique guide for the measurement procedure. What kind of instruments we can use? A wide range of instrumentation can be used to verify compliance with our clearance level. Just to give an example, we can use proportion counters, plastic scintillators, solid state detector, bulk monitor, in situ gamma spectrometers, and of course the choose one instrument or the other is strictly connected from what we want to measure in terms of object itself and of radiation we want to investigate. So as is written here, so we need to exactly know to be able to choose our instrument, we need to know the radionuclides of interest, the type of emission, if it's alpha, beta, or gamma, the emission energy, the type of contamination, if we want to look only on the surface, so we need to have information on the entire mass, the possible use of the correlation factor, if we have only radionuclides easy to measure or the so-called difficult to measures. And of course, the nuclide vectors. So if we have some radionuclides, let's say more important than the other. The detection limit of the instrumentation for the reference radionuclides must be such as to allow the applicability of the removal condition for each radionuclide present, and in any case, less than 50% of the removal level. That's a very important information to choose the correct detector. The assessment of the activity concentration in material, for example, let's imagine a concrete block, is based exclusively or partially on measurement of samples. Sample measurements are used to obtain information about the distribution of the activity inside the material to decide when it meets the clearance level. The minimum number of samples needed for a statistical verification of clearance condition depends on the median and the standard deviation of our measurements, of our results. The number of samples needed to make a decision on the removal increase rapidly to closer the median value is to the removal limit, and the higher the standard deviation of the measurement. So the statistical method we can use can be found in the MARSIM. And there are several that we can use, and the Italian law doesn't give us indication which one to use, especially because it depends from your measurement and your assessment. Okay, so at this point, theoretically, we have taken measurement with instruments. We have taken measurement of our sample, so we have all our results, and we can move to compare our results with the clearance level. Compare measured values in the Italian clearance threshold means to check and compare them with the levels defined in the Annex 1, Table A, or our legislative decree. And of course, the Italian decree is not just written out from nothing, like all the European countries. Also, our decree is based on the European guidelines, and in this case, is based on radiation protection 113, 89, and 122. If the clearance level are exceeded, the material must be decontaminated or segregated for conditional clearance or treated as a radioactive waste. After the decontamination, we reset new measurement till we reach, and not just reach, but we are under our clearance level. At this point, we can finally submit a formal clearance application, it's called istanza di rilascio, to the competent authority. The istanza di rilascio must include several topics, so there must include inventory of materials, the measurement reports, the description of methods and instruments used, the declaration of compliance with clearance level. At this point, the competent authority verify the compliance of our istanza di rilascio with the legislative decree 101 and the adequacy of the methodology and the documentation presented. The control authority may perform site inspections or independent sampling, and once the application is accepted, finally it issues the clearance authorization. So that's the theoretical part. Now let's move on the reality. And I want to present you some practical examples. Of course, I will show you some activities we follow with my company Nucleco. Nucleco is the Sogin Group company leader in Italy in the field of radiological services, management of radioactive waste, decontamination and remediation of nuclear plants and industrial facilities. Is responsible for the remediation of plants, infrastructure, and land affected by chemical and or radiological contamination. And of course, in this for that point, we very often request authorization for clearance of material or part of the nuclear installation. The activity I want to show you is an activity of removal, containment, and management of hazardous and radioactive waste, and of remediation and environmental reclamation of an abandoned storage in the surrounding area of it. So I cannot specify exactly information about where this site is and what was inside, but that's not really the point of our lesson. Our lesson is more about introducing you what we have done to arrive at the clearance of this nuclear installation. So this activity actually was organized in two main sub-activities. First was the removal of the radioactive waste from the building. And the second sub-activity was, of course, the remediation activities for the final clearance of the entire site. So I don't know if you can see, but from the picture, can you see my mouse if I move it on the page? I hope so.
Yes.
So cool. So as you can see in this picture, the funny red rectangle is the area we are working in, and is composed from a giant building that was used as a storage of radioactive waste and all the area around it. First of all, to release and then release to ask for the clearance, we have to remove all the radioactive waste inside it. So the removal was the first point. And to do that, imagine that inside this building there were roughly 20,000 drums of radioactive waste. And because the storage was completely abandoned, was important to reconstruct all the historical information about it. Watching all the papers they were left inside, papers and documents they were left inside the storage, and try to understand also from the newspaper, the mass media, and so on, all the information were officially known about this site and what was done inside it before it was abandoned. This point was crucial to reconstruct the radiological inventory, and without the radiological inventory you cannot plan absolutely anything in the nuclear field, because you cannot plan how to remove the waste, how to eventually ask for a clearance authorization. From the let's say technical point of view, was important to verify the integrity of the drums containing the radioactive waste, to understand how to remove them from the storage. And if necessary, we had to intervene to secure the damaged drums. Once all the drums were in good condition to be transported, we had to plan and execute the removal of all of them from the storage site, taking care of them, management, and treat them as radioactive waste, of course. Once our storage was finally free from radioactive waste, we could start our remediation activity with the idea to ask a clearance authorization at the end of everything. Of course, the information, all the study we have done in the previous phase about reconstructing the historical information was crucial and very important because we could understand what was the radiological inventory that is shown here, and to understand what kind of radionuclides to investigate. So first we have done was the emission of a radiological characterization plan. Inside it was written which kind of radionuclides to investigate, thanks of the information reconstructed with the historical assay, which instrumentation and measurement techniques to use for the detection, because as you can see in the table, the radionuclides are very different. I mean, we have some radionuclides that are gamma emitters, some pure beta emitters, so we have a bit of everything. And which total activity and contamination values to reach, so declaring the clearance levels, and what material we need to check and verify for the unconditional release. Our remediation activity for the fire and clearance, I mean, we can think about it as two big parallel activities. Once we had the measurement and the clearance verification of the storage building and the external area of the building, and on the other side, we have the measurement and the clearance verification of all the materials left inside. Of course, material that were not radioactive waste. All the radioactive waste were already removed. So for example, here, these are empty drums. So they are not drums full of anything, but they were there, so we had to care about them. So for the clearance of the building and the external area, what are the steps to follow? What are the steps we had follows? First, of course, the mapping of the full interior surfaces of the building. And when I mean all the surfaces, I mean really everything. So the floor and all the walls of the building, and also the roof internally. And we had to map also all the surface of the external area. And we are talking about really a lot of mesh. As you can see here in the pictures, we literally drawn down all our meshes. And we are talking about around 1,000 meshes for the entire building, and roughly more or less for the external areas. So really a lot of measurement to perform. Once we have drawn everything, we started the verification for every single mesh inside the building and in the external area of dose rate and contamination level. Once we measure all the mesh, we could measure all the mesh with the gamma ISOX instruments. That actually was done for the mapping inside the building to verify, or at least to exclude, the presence of gamma contaminants. But of course, for the external area, the ISOC measurements were not took into account, also because in the past we have done some measurement on some samples, and we already could exclude the presence of this radionuclide, but mapping is necessary as well. And of course, I don't know if you remember, maybe I can scroll very fast to show you here. So from the radiological point of view, the radionuclides we have, as I said before, were not just gamma contaminants, but mostly beta emitters like tritium and carbonium. And as you know, this kind of emitters cannot be absolutely detected with an ISOC instrument, and we could correlate the activity, but in case of free release, is preferred to have a direct measurement. And the only way to obtain value for beta emitters is to perform laboratory analysis on samples. So we took some samples. Where did we took them? Actually, during the mapping, the initial mapping on the building surfaces, we were taking attention to the area where was present some spots that could be reconducted with some loss of radioactive material during the storage time. And on these spots, we took our samples and perform the A analysis for the identification of our beta emitters. Actually, I forgot to say that just immediately before taking the samples on these spots individuated, we also have operated decontamination activities, to try being sure that any contamination was left. And that was for the building and the area surrounded. For the materials that was left inside this area, as you see, we had different kind of objects from pieces of wood, pieces of metal, empty drums, and a lot of other stuff. So the first point to our clearance verification of these materials was to perform a very detailed inventory of our materials. And for every single pieces it was found, it must be verified the dose rate and the surface contamination levels. And also in this case, we are talking about really, really a lot of measurement to be done. Once we had the detailed inventory, and we verified all of them, considering what of this material, which of this material was contaminated and which not, we could prepare a batch of objects, dividing them for different materials. And the preparation of the batch was made in accordance with European guidelines for free release. It means that they must have a regular geometry, and in case of metal material, the total amount had to be lower than 400 kilograms. And for the other materials, we could arrive at 1,000 kilograms. The regular geometry we could perform was the cylindric geometry, the cubic geometry, actually these two. So for the cylindric geometry, for example, as you can see here in these pictures, we had a lot of metal tubes. We cutted them at the dimension of a drum, and we used the empty drums you could see in one of the previous pictures as a containment of these cutted tubes, paying attention always, of course, to the maximum mass value we could obtain to not go over the 400 kilograms request. And some of the drums were not used in this way, were reduced in the dimension in this way and combined to have a cubic geometry of course, also in this case, with a total weight not higher than 400 kilograms. Then all the wood materials we had around was cutted and was combined together to recreate these cubic materials as well. And all the other materials we found, here I put some picture about that's paper, that's plastic. There were a lot of other materials. They were divided and put in the giant big bags that are already, a regular geometry. Okay, so once we had our batches, we could measurement for everything of them gamma emitters with ISOX instrument. And we took samples to perform the A analysis, also because the radionuclide of reference were still the beta emitters. When this part will be ended, we could finally compare the results with the survey, with the clearance level. Okay, once all the remediation activities will be ended, will be officially requested the release of all the materials. And what we will request, actually, the free release if clean of radiological contamination, or at least with contamination levels under the clearance level. We will ask the conditional release where, and if possible, if the values will be not under the clearance level. And we will ask the authorization to remove the material that presented a contamination. And it will be removed, of course, as radioactive waste. On the other hand, we will request also the release of the building and the surrounding area. And we ask the release to reuse of the building. So as building, the release to reuse as a building with new purpose, or we will ask the release to them, the authorization to demolish and to use the area for some different purposes. And once we could submit this official request, actually we will have the chance to be authorized to clear all the area and the materials. And I guess that's all. So thank you for your